Day 9, and I'm Alok. So what are the objectives of the day? Very interesting day, and we will be learning about understanding the IP addressing. We will understand how the RHEL 7 network interface naming works. Very interesting and something very new which is in RHEL 7. It was not there in RHEL 6. How to view the existing network configuration using commands like ifconfig and IP commands. A couple of commands you might be knowing already. Then changing the network configuration using the nmcli tools, then changing the network configuration using the configuration file itself, and then finally we will be seeing how to change the host name, the DNS name resolution things using the etc host and etc resolve.conf file. That's great. So let's start with the first objectives, understanding IP addressing. So what is IP address? IP address is an address which is used to identify a device on an IP network, as you can, and you will just see it on the screen. I'll be sharing a picture here. Here it is. So IP address is of 32 bits. It is divided into a network portion and a host portion with the help of a subnet mask like /8/16/24, and the whole 32 bits are divided in 4 octets, and one octet is equal to 8 bit, and octets are separated by dots. You can clearly see it here. Octets are separated by dots, we call them period. And IP addressing was first standardized in September 1981, which is fine as far as the history is concerned. And IP is divided into 2 parts. One is, the first part identifies the network on which the device is, and the second part identifies the particular host on the network. And further, IP address is divided into some classes. We call them class A, class B, class C, class D, and class E. So IP address is then divided into these classes: class A, class B, class C, class D, class E. What is the idea behind these classes? Why should I be using these classes? Because the IP is already divided into say 4 parts, octets and all the things. So you can see here, class A, class B, class C are the major classes. These are the classes which are assignable to the public. Class A has got first octet as the network ID and the 3 octets as the host ID, and the value will be from 1 to 126, and you can have 16777,214 host in the host block. Then class B is ranging from 128 to 191. So where is 127? Remember this, 127 worldwide is reserved as the loopback address, and it cannot be used as a valid IP address over the internet. And then class C is starting from 192 to 223. So these are the major assignable classes. And then further, we have got a special purpose classes between the class A, class B, class C. We call them the private IP address range. So in class A, I have got IPs from 10.0.0.0 to all the way back to 10.255.255.255. This is a private class. What do you mean by private class? Private class address means any company can use IP address within their LAN segment freely, without charge, without any legal hassles. And class B has got 172.16.0.0 to 172.31.255.255, and class C private range is from 192.168.0.0 to 192.168.255.255. So you might have seen that we normally use within our environment, we normally use IPs of 192.168. So if I show you, it's 192.168.0.100. So it's a private IP range. So even I am using the private IP range because it's for within the LAN segment. So what is private IP? What is public IP? It's not getting into me. Okay, let me give you a very simple example. Now, here is this street. You have got the street here. You can see here. There are some houses here. So IP address is similar to a street. A part of the address, street address, is the network address. You can see here 192.168.1, which is in green, is the network address which identifies the street, and then .20, .21, .22 are individual houses or the host. So the pink house will have the complete address of 192.168.1.22, and the green house, the first house, which is like slightly green in color, will have the complete IP address of 192.168.1.20. So the network ID represents, or the street address represents the network ID, and the individual houses addresses are the host IP address. That's fine. So this IP range is a private IP range. As I have told you, I can classify further IPs into two categories: a public IP which can be accessed from anywhere, and a private IP which cannot be accessed from anywhere and are normally hidden behind a device with a public IP address like a router. So now if you see this new picture, I have got two more buildings with a public IP address. So the pink building has got an IP address of 54.3.88.2. So it's a complete address. It's not the network ID. And the green building has got an IP of 68.43.21.7. So these are the public IPs. These are complete addresses. So these IP addresses are accessible from anywhere in the world, or they are visible to the entire internet. But how can I use a combination of public IP and the private IP? Okay, let's see this third picture now. And now you can see I have used public IPs and the private IPs. So now I have put a building on the street, right on the street. The pink building is right on the street. It has got two interfaces. If you see here, on the left hand side, public, where the public is mentioned, it has got the IP of 74.10.10.50, and on the private address, on my street side, on my right hand side, it has a address of .1. So the complete address from the street side will be 192.168.1.1, and from the internet side, from the public side, it is 74.10.10.50. And if you see here, so this actually acting as my router. What is a router? So the whole street, the guy there who is standing in between house 1 and 2, between house number 20 and 21, he has to go to IP address of 192.168.1.1, which is the router interface, and then using that building he can go to the other side of the fence. As you see there, the fence is also there. So fence, you can consider it like a firewall that blocks the rest of the internet from seeing the addresses on the street. So the building is acting as a router or the gateway, and it also controls what messages will be traveling between from inside my street to the outside world. So on the street side, it has an IP address of 192.168.1.1, and from the public side it has got, or from the internet side, it has got the IP of 74.10.10.50. So this is actually how your public IPs and the private IPs works, and I hope you will be able to understand the significance or what exactly the router is. So once this is done, we will be jumping on to our second objective to understand the new network interface naming convention in RHEL 7. So let's move on to that. So once we have understood the basic IP addressing, now let's understand the new network naming convention in RHEL 7. So if I show you one very interesting thing, I hope you might have noticed it. If I give ifconfig, you don't see ith0 and ith1, the traditional way of assigning the names to my LAN cards. So the classic naming convention for the network interfaces was applied actually by the kernel, is to simply assign the names beginning with ith0, ith1 to all the interfaces as they are probed by their respective drivers. So now, because the driver probing is generally not predictable, so that means as if you have multiple network interfaces. Remember, so the first driver probed, it has assigned the LAN card ith0. The second driver has probed or activated, it will assign his LAN card ith1. So, but the driver probing is not predictable. And if you have multiple NICs and they are available for the assignments of name like ith0, ith1 and so on, it is not fixed anymore. And it might happen that ith0 on one reboot, after one reboot, may end up as ith1 on the next. So it can have a serious security issues if you have configured the firewall based on the interface names. So to fix this problem, they have used the new naming convention. So to fix the problem of multiple interfaces, they have proposed and implemented a new naming convention. So now you won't see ith0 and ith1. So what happened now is that I will be requiring a different type of naming convention, which they call it the consistent network device naming, and it is being implemented by a package named BIOS dev name. If I show you this RPM query here, this is the package and the UDEV rules which are responsible for this kind of naming convention. So what it does, the BIOS dev name implementation, it tries to find the fixed slot topology information in certain firmware interfaces, and it used to assign them a fixed name irrespective of the physical location on the motherboard. So that means, so the fixed names are based on firmware, topology and location. Now if you see this picture here, I'll just show it to you. So now the names have got, so if I have given ifconfig here, you see en, so certain naming has been assigned, the predictable names are being fixed. So en stands for Ethernet, as you can see in the picture right now. En stands for Ethernet, WL stands for wireless LAN, and if the name is starting with WW, it is a wireless wide area network. And O is for the onboard device index number. If you have got S here, it has got a hot plug slot index number. X can be used for MAC address, and PCI geographical location will be specified by P and S. So this is the new predictable naming convention in the RHEL 7. So how it works, I'll just give you one simple command here to show you. You can use the udev command, one very interesting udev command. I'll just give it here. to show you how the naming works. So if I give a here command here, udiv adm, sorry, info, and first I'll just show this that I'll just copy my, so that means I've got an Ethernet onboard card with this index number. So let's find more information about this. It's not there in your book, but I'll just show it to you. It's very interesting. So copy that name, udiv adm info -e, and then grep for certain characters here, a10 caret capital P dot asterisk and then your number. See here, it gives me all the information about this particular device. So this device is the whole information, right? It's a gigabit Ethernet controller. It's on board. This is the MAC address of my LAN card. So if I give if config here, you see it will match here 000C29, the same MAC address is coming up here, and this is the onboard name, and the PCI slot name is ENP2S1. So you will get a lot of information about a particular device, and you can also find the index number. I'll just give another command here, just search for it. You can find it in your respective machines. Do a grep of my eno. See here. So this is the location and this is the PCI slot index number, which is showing up here. So if it is eno, that means it's an onboard. If it is a PCI card, if it will be a ENS or ENPS. So this is being controlled by systemd and the UDEV naming convention. And I'll repeat again, it's based on firmware, topology and location. So just by seeing the LAN card number, you will be able to see. And if so what are the benefits? What are the benefits of this? If I show you one more picture here, just a moment, let me see if you see this picture here, this is the hierarchy in which the new names are being assigned. So number one scheme is that it will use the names will be used incorporating the firmware or the BIOS index provider like ENO1. Second scheme is that it will use the PCI Express cards or the slot index numbers like ENS. If these two fails, then it will go to the physical location of the connector of the hardware like ENP2S0. And if this also fails, it will be taking the MAC address of the LAN card. So that means if I give this same command here again, so if everything fails, it will show me this device, the MAC card. And if finally everything fails, it will go back to the unpredictable traditional method and will show me my device as it's 0. That's fine. So the benefits, what are the benefits? We have understood this naming convention. So what are the benefits? The benefit is that you have a stable interface name across the reboot. It will not change. You have the benefit of stable interface name even when a hardware is added or removed. Stable interface name even when the kernel or the drivers are upgraded or changed. And stable interface names even if you have replacing a broken or a damaged LAN card. These are the benefits, and the benefit is one, that is you've got a stable naming convention, consistent naming convention. So even if you change the slot of it's 0, it's like suppose if you've got two LAN cards, two PCI LAN cards, right? You have connected it on the board. So even if you change the slots, the naming will remain the same. That's good. But in case, again, it's not a part of your courseware, but I'll just explain it to you. In case you want to disable it, so the easiest way is that you can pass the kernel parameter and disable it. I'll just show it to you. So if I do a if config here, you'll seeing here, it's coming up as the persistent naming convention So I just do a reboot of this machine of server 1 and just wait. And while starting up here, I press let's wait. See if it works or not. So the easiest way is this, though there are other ways also. I hope you can see it. It's revert to H0. You've got your old naming back if you like it, though I won't recommend it. So you have got H0 coming back. So now we have understood the naming convention. Now let's move on to the next objective, that is how to view the configurations, how to check the configurations. Let's do it. It's a very small thing. So couple of commands that we'll be using here, very simple commands. Like you can check the IP address of your machines by the ifconfig command, though it's an old command and it's being depreciated now, but you can use it. Okay, it's still coming as H0, no issues. Then we have got IP commands in RHEL 7, so you can give IP address show. It will give you all the LAN cards and their respective IPs. Okay, so same here, or you can give a shortcut here, IPAS address show. You can get more information about how much traffic is flowing through a interface is IP link show, say it's 0 or whatever name. So how much packets are received, dropped, you will see it. Then you can also get the information of your routing table. One is the route-n command, other is the IP route command. It's solely up to you which command you wish to use to check your routing table. Obviously you know the ping command, so I need not to explain that ping command. How many sockets are open in your machine, that you can find out using the ss command. So if I give a man of ss, you'll see here to show the sockets, to investigate the sockets. So if I do a ss-ta, there are a lot of options here. So if you see here, all these, so SSH is open, right? Apache is open. These ports are open up here. So this is it. So it shows that SSH is listening on all IPv4 addresses if I have got multiple LAN cards available. Then your Let's see which FTP is again listening on all the your loopback. FTP is listening on all the like interfaces. So IPv4, IPv6. So this will be shown to you. So T actually stands for the TCP sockets and A actually stands for the all the sockets. So if you are interested in seeing the UDP, you just need to replace the T with U. So all the UDP sockets. So you should be able to check your IP address, check how many ports are available, and you should be able to do a ping to the other machine. These are the basic things at least you should be knowing. Now the next part is, once we have seen it, now how to change it. How to change your IP configurations. Say I need to change my IP address. So how can I change it? So we will be using the nmcli tool to change my IP configurations. So nmcli is a daemon that monitors and manages all your network settings. And if you want to understand the network manager, so actually network manager is the daemon, nmcli is the tool. I'm sorry if I have goofed up there. So nmcli is a tool which the network manager uses, which is a daemon that manages all your network devices. So if you have to understand the like network manager and the nmcli, we need to understand two things: device and a connection. So let's first understand what is a device, what is a connection, and then we will proceed further in creating the or changing the LAN cards, IP addresses. So let's do it. So let's start configuring your our LAN interfaces using the nmcli. So number one thing we need to understand is that when we talk of the network manager and we talk of changing the IPs or configuring the IPs, we need to understand two things: device and a connection. Connection is actually the thing which will be having your IPs, your gateways and everything, and device is actually the physical interface card, NIC card, which will be connected inside the connection. So if I give the first command nmcli connection show, it will show me the all the connections. These are the connections to me. So Eno 776, right? I have got a wired connection, and these are the devices which are plugged into those connections. So I have a connection named wired connection 1, which have my eth0. eth0 means this, the same device which I had my Eno like device which I had reverted to the original one, or the old naming convention. So if I want to go back to the new naming convention or the persist naming convention, I'll just do a reboot. So it will come back to the RHEL 7 new naming convention, as I will not be passing any kernel parameter here of net dot if names is equal to 0. Let's wait and then we'll proceed further. Just a moment guys, the machine is coming up and then we will start. There's very simple stuff. Just understand connection and device. Connection will be the logical entity which will be holding your IPs and everything. Device is merely a physical device which you will be connected inside the connection. So consider connection as a switch which has got the IPs and all the things, and device is the actual LAN card which will be plugged into that switch. That's it, so that it can use those configurations. So I go back here, so just check it out, adjust my settings for the aesthetics of the video. I'll go here. If I give a if config, I have revert to the new naming convention, and if I give a nmcli connection show, you see I have get this wired connection 1 and my device, my LAN card is connected in it. So if you want to get more information about a connection, just copy it and you can see, give the name nmcli connection show, or con show will also do the thing, con show, and the name of the connection. So I paste it here. So it gives me a complete detail about that connection, that auto connect is yes, it will be auto connected after the reboot. The MAC address is this, which right, and the IPs, it's a wired connection. IP address is this, the gateway is this. So you've got a lot of information about the connection. You can get the information about the devices also by the dev status command. You'll see there all the devices and in which, so dev status and connection status will simply reverse the things. Here the devices will come first and the connection in which they are connected, and here you will find the connection names will be coming up and then the device which is connected. And if you want to get information about a particular device, say I want to get more information about this device, I'll just copy this and then I can give the command nmcli dev show. Very simple, like con show. You will get complete information about it, the device name, the MAC address, the IP address, whatever is assigned to it. So let's create a one more connection. Up till now we are only seeing the things. Let's create a connection and then add my device in it. My device means my this Eno device in it. So I'm creating a connection, say office. So I give a command nmcli connection and root. It's very simple. Actually, you might find it difficult to remember, but a good admin will always know how to take help. So just press tab, that's all. 2 times tab. It will automatically give you all the options. So what I intend to do, I intend to add a connection. Okay, so I give add. That's great. What next? Give a double tap once again. Because you are creating a connection, so you should be giving some connection name. Give con name. Now give any name. Say I give office. Anything. Okay. What next? So if it is a connection, I should be having a interface name, like the connection interface name. So I can give it, say I give if name, and then any name will do. You can give any name, whatever you want to do to this interface. So the connection name is, say office, and I will be adding a interface in it. So which interface will be connected to it? So this is my interface. So I give interface name is this, and type, if you again press 2 times tab, type again tab, obviously it's a Ethernet connection, Ethernet. What next? I have to assign IP4. And then any IP address that you wish to assign. Say I give here 192.168.0.100/24, and I can assign the gateway also by, if I do a tab here again, keep on pressing tab and you will learn all the options. Need not to cram those things. So I give here 192.168.0.254, anything. Connection office created successfully. So if I give this command nmcli connection show, this is the connection. So connection is again a interface, but I cannot see my interface here. What was this command then? So if name is actually the name of the interface name which is given to the connection. So it can be anything, say static or anything. Because I intend to use my same interface or device, I had used this name. Okay, so the connection is there, but is any device connected? So I just give, oh sorry, so if I again give nmcli connection show, my device is not connected in it, right? See, office is blank, it's not getting any device. So if the physical interface is not there, then it's of no use. So I just need to give up nmcli connection up, and then my connection name, whatever, office, oh sorry, office. So if I give the same command again, see here, now my device is connected. So if name was that which device will be participating in it, in this connection. So as soon as you make it up, that device will automatically get connected here. And if I give ifconfig here, I'm getting my IP. My IP is coming up here. So if I give a here nmcli connection show, my office connection and my device is connected to it. So you need to make it up. Unless and until you need to make it up, it won't be effective, right? Effective. And to view that which connection is active, you can simply give nmcli connection active. Con show -- active is the command. So these are active connections. So just focus on this one. And I had verified the IP also. So in this manner, you should be able to, I'll just repeat, you should be able to create a connection, assign an interface in it, and then assign the IP. So it is a very important point, as it's an exam objective also. So you should be able to do this. We will be coming on to a lot of other things like team interfaces and all those things in the essay 3, not now. Then the next way of changing the, so it's nmcli is one of the ways of changing the your IP configuration. Another is nmtui. You can give nmtui, it's a tool here. You can edit a connection, activate a connection, set the host name. So I say edit a connection. See here, my office is coming up. I press here, go edit. I can change anything, do it like this. So it's up to you whether you want to use nmtui or nmcli. So keep on moving, guys. I'll just do a cancel here. You can add a quit here, change all the things. So nmtui can be used or nmcli can be used. Another way of doing it is that I can directly change into the network scripts or the files. So you know that all the IP configuration, you should remember this, will be going under this folder etc sysconfig network script. So if I give a ls here, you will find all the interfaces are coming up, my connections are coming up. Can you see it? So if I do a if cfg of office, it's the IP. So what is the benefit of connection? I'll tell you. I'll give you one more example. So currently, say this is a machine or my laptop which I use both in office as well as in home. So I have a connection office which has got this IP address. Fair enough. Which is my office network range. So I create one more connection here. See here now. I just repeat it. Here it is. I create a connection name, say home. Home. Interface name is this. Type Ethernet. Obviously, type is Ethernet. What next? Again, do a tab here. IP4, or I say auto connect yes or no. So if I say auto connect yes, so that will be connected automatically. So I will not use it auto connect yes. So I give IP4. See here, or IP.method is there again. So I give IP4. I will just give another IP address, say 10.10.10.10/8, and the gateway is again GW4. Gateway is say 10.10.10.254. Connection home created. So what is the benefit? I'll show it to you. If I give a connection show, I've got two connections, but currently the IP I'm getting is 100, which is from office connection, because my device is connected to the office connection. Now when I go home, I just need to give this command. See here, I need not to change anything, doing it manually. I just need to see nmcli connection up home. That's all. So if I give a ifconfig or ipas now here, you will see my IP change to 10.10.10. That makes my life much more easier. So for every location you can have a different connection, might be from static or DSCP. You can do all these things. So now coming back to how can I change the IPs from the scripts, from the configuration file itself. So let's go back here. So you should remember this location, that the IP configurations goes up here. So you will have home here, office here. So any point of time you want to change any like configuration, you can directly go into the like script and change it. Say I give ifcfg home. So currently if I see my IP is 10.10.10.10. okay, so I can change it from here. ifcfg home, I go home, I make it 100, just 100. That's it. So you can change it from here. Anything you can change it from here. You just be careful, because you are modifying directly the configuration file, and just need to do nmcli connection reload as you have done the changes here. And if I give ifconfig, can you see it? It's still 10. It's not coming up. You need to make that connection up again. Don't forget this connection up home. So if I try to see it, you will find 100 coming here. So in this manner, you should be able to modify the connections by directly moving into the network scripts directory and changing the configuration file. So it is one of the easiest way, but it's solely up to you what exactly or how you want to proceed. But you have got all the ways: nmcli, nmtui, and then directly editing the conf file. Now let's move on to a very small topic here of this particular day, for the day, how to change the host names and how to redirect your machine to the DNS server. So you can have the host name, the current host name can be seen by the command hostname. That's fine. And if you want to have a static host name, then you should be editing this file etc hostname. You can change the host name from here also. So if I do a .com, I'll just show it to you, right? And I give the host name here, it's .com coming up here. You can change the host name from here also, or there is a command there, hostname ctl. You can use this --help. Again, you have to be smart. So set host name will be the option. So I give the same command I give set -host name, and then I'll go back to server 1.networknuts.net. It's changed. So if I do a cat of etc hostname, you see it's changed. So this command actually modify the file, and this hostname actually read this file. You can change your host name by the hostname ctl command, or by directly modifying the etc hostname file. So in the previous versions of RHEL 6 and RHEL 5, the file used to be etc sysconfig network, but not anymore. The file used to be this, but not, you should not be editing this file now. You should be directly modifying the host name file. See, it's created by Anaconda, but it's blank here. In the same manner, if suppose you have a DNS working somewhere inside your infrastructure and you want to point your machine to the DNS, so the file name that you should be looking for is the resolve.conf. So resolve.conf is the file which will be pointing to your DNS address. So it just contains two names. I'll just give a very simple example here. Though we don't have the DNS, search domain name and the name server. So let's presume that my IP is the DNS. I give 100 here. That's all. This is, so means go search in this domain, and my name server or the DNS server is running at this IP address. So you can change it from here. Cat etc resolve.com. And like remember one thing, if you modify the configurations using the nmcli tool, so it will modify the your resolve.conf file. I'll give you one simple example. So currently it is resolve.conf is having 100 here. Now if I give the command nmcli connection modify, right, and what's my, let me check my connection right now, nmcli con show I'm at home. If I give this command and nmcli connection modify home ipv4.dns, see that you will find this 4.dns, and then say I give 10.10. say 10.111. Done. I've changed this. So if I show you the htresolve.conf, obviously I need to do a connection up and down, because remember one thing, whenever you do it, you need to just kind of refresh the connection. So home and up home. After this, hopefully I'll be getting my name server back. So make sure that if you modify the connection using the nmcli, it will automatically change the resolve.conf. You can have multiple DNSs also. So for that you just need to give a plus symbol here. That means don't remove the previous one, add one more, say 222. So again I need to give a connection down and connection up, and if I do a cat, I have got two name servers coming up. So it is again one of the exam objective that you should be able to have a specific DNS address pointing towards, so that anything, whenever you try to access any host name with a name, your machine first go to this your resolve.conf. It will find the IP address of the DNS server and will go and resolve the name. So at least you should be able to do all this thing. Connection, you should be able to add a connection, and you should be able to like modify a connection. I have just shown it to you. And you should be able to change the IPs and all the things directly from the script. So that all you need to understand. So the exam objectives are very simple. You should be able to create a connection, add a device into it, assign a static IP address, and you should be able to change the host name and configure your machine for a specific DNS server. That is here for this day. And tomorrow in the next class we have a very interesting and a small topic of using the tar commands for backup, rsync and scp. So all these commands will be taking up into the next class. And though we had already done the yum install, yum update, how do you use the yum, we had done it in our I think earlier classes, so need not to go through those. We will be learning about the tar, scp and rsync things. So I'll see you again in the next class. Till then, do this your nmcli. You need to make sure that you have a very sound understanding of connection and devices. Thank you very much. See you again. Bye bye.